Alright, continuing 2.8, number 22 states a boat is pulled into a dock by a rope. There's the rope right there. Attached to the bow of the boat, okay, and being pulled, passed through a pulley on the deck that is 1 meter higher than the bow. Okay, there's the bow. So, this is 1 meter high. So let's call this R for rope. If the rope is built in, the change of R with respect to T is 1 meter per second. Alright. And how fast is the boat approaching? If I call this X, we're saying the X dt equals what? When it is 8 meters away. Well, first things first, I need an equation. To combine those, I know that R squared equals 1 squared plus X squared. 2R dr dt equals 2x dx dt. I could divide by that, save myself some time. Now, I know what x is. X is 8. Dx dt is what I'm looking for. How fast is the boat approaching? Dr dt is 1. I still have to figure out what R equals, and now I put in the information that I have. That is, if this is 8, this is 1, isn't this the square root of 64 plus 1, 65? So can't I say here that dx dt would be square root of 65 divided by 8, and what are the units? X is in meters and per second. So that's a bit faster than 1 meter per second, right? 24, a particle moves along the curve y equal the sine. As the particle passes through the point 1/3 1, its x coordinate increases at a rate of radical 10 centimeters per second. Okay, how fast is the distance from the particle to the origin changing at that time? Alright, well, let's get this. I'm going to sketch a graph of this really quick. Okay, well, the period is pi over 2. 2 pi divided by pi over 2. Which is 4. So 1 each. This is 1. This is y equal 2. And about 1/3 of the way, let's say about right there. This is happening at 1. 1/3 is really right there, but it's okay. Just to see it. So this is the point x, y. When you put in there 1/3 for x, you're getting a 1 for y. Alright. It says, as soon as it passes through that point, the x coordinate is increasing at a rate of radical 10 centimeters every 1 second. How fast is the distance from the particle to the origin? So this is the origin right there. And there's the particle, let's say at any given point xy. There it is. And if I want to find the distance, well, this is x, this is y. If I call this distance s, I would say s squared equal x squared plus y squared, but I know what y is. Y is twice the sine of pi x over 2 squared. So s squared is actually x squared plus 4, the sine squared of pi over 2x. That would be my equation, and now if I take a derivative of that, 2s ds dt equals 2x dx dt plus, bring the power down, subtract them from the power, times the derivative of the inside, which is the cosine of pi over 2x times pi over 2. And I have an x evaluated at x equal 1/3. So twice, I'll get ds dt in a minute. That's really what I'm looking for. Twice x, I know that x is 1/3. dx dt they gave me to be radical 10. I know there's an 8. I'm going to shift this just a bit to the right. 8. The sine of at 1/3, that is a 1. That's going to be the sine of pi over 6. That's 1/2 actually. And the cosine will be radical 3 over 2 times pi over 2. So everything's there except, oh, I left out dx dt times a radical 10 as well. Now to figure out what s is, I know that s squared equals 1/3 squared plus 1 squared. That is 1/9 plus 1. All over 9, that's 10/9. So s is actually radical 10 over 3. And now I could say ds dt will equal, and you know what all of that means, twice radical 10 over 3, plus you could simplify those 3 2's, cancel that. You're looking at radical 30 pi, all divided by 2 radical 10 over 3. Again, on a test, this is more than enough. You could multiply by the reciprocal and clean that up if you wish. That would be 2 radical 10 plus 3 radical 30 pi over 2 radical 10. You could rationalize. That's not as important for me as the units. What would be the units for this? Wouldn't that be centimeters per second? If I move to the next problem, a trout 10 feet long and its ends have the shape of an isosceles triangle 3 feet across. Okay, so something like this. When they say the height or the length, that's the length. This is 3. This is a 1. Filled with water. You're pouring water in at a rate of 12 cubic feet per minute. How fast is the water level rising? If I call this H, how fast is the water level rising when H is 6 inches? Well, everything's in feet. 6 inches, isn't that the equivalent of half a foot? Remember before this pandemic you used to go to Subway? They would say, oh, would you like a foot or 6 inch? Half a foot. Well, how do I, this is a prism. If I put this on the side, it looks something like this. And if I know from before, volume of any prism is area at the base, that's area of the triangle, times the height. Volume is, the height is fixed, that's 10. But area at the base, that's one area of the base, correct, I was right. 1/2 base times height. Well, we know the base is what? A 3, not really. The base of the water. Water is filling up. Do you see? It's not full of water. If it was full of water, then yes, you could use the 3. Common mistake that students do. If I take this triangle, this is a 3, and this is a 1. It's not drawn to scale. You know what? Let me make it wider. it'll help. If that's a 3, let's say that's a 1. Since that seems to be the challenging part for you. Oh, come on. Okay. Here. Now, this is 1. And this is 3, the whole top, right? So, the water level is really this high. And that's the height they're talking about. So when I say 1/2 base times height, well, they're talking about this base and they're talking about this height, the actual liquid. Well, let's see how that works. If I take 3 to 1, that should equal this b to this height. So if I cross multiply, the base is 3 times the height. Now, I need to eliminate the base out of the equation because I have information about the height. So this volume is actually, when you multiply those, that's 5. The base is 3h and the height is h. And that's the hardest part of the problem. We all know what to do once we get this. We all know you're going to take a derivative and you're going to say dv dt is going to equal 30h dh dt. That part is easy. dv dt was given to be 12 feet per minute, 12 cubic feet per minute. So this is 12 equal 30. H was a half dh dt. And I could easily say dh dt would be, this is 15, 12 over 15. You could reduce that. What are the units? The water is being leveled, is measured by feet every 1 minute. So at that instant, that's how fast the water is rising. On number 30, it states a kite is 100 feet above the ground, moves horizontally. So it moves horizontally. I call this x. Dx dt. Okay. Dx dt is 8 feet per second. At what rate is the angle between the string? The string would be right there, S, and the horizontal, So if I mimic this, this is x and this is 100. Now I have multiple options. That is, I could say 100 squared equals x squared plus s squared. Well, that wouldn't do me any good because the angle is not in there. I have multiple options for the angle. Keep in mind what I have. I want to include the angle, the x. I could include s, but isn't it easier to include a constant because I have no information about s? Isn't it easier to say the tangent of theta is 100 over x, or 100 x to the negative 1? And if I take a derivative, secant squared of theta d theta dt equals negative 100 x to the negative 2 dx dt. Or secant squared of theta d theta dt is what I'm looking for, equals negative 100 over x squared, and dx dt is 8. Okay, a few things I need to find. Okay, if they say you have a right triangle, this is the angle. If this is 100 and this is twice that, that makes this radical 3 times this. Or you could use Pythagorean and figure it out. So basically, the secant is the hypotenuse over the adjacent, d theta dt equaling negative 800 over, and x in this case would be 100 radical 3, and d theta dt would be negative 800 over 10 radical 3 divided by 200 over 100 radical 3 squared, and that would be radians per second. And there's the homework. I would have simplified this, but I'm out of time.